This is graphing the inequality on a coordinate plane. So we've been graphing them on a number line. So what would it look like if you graphed it on a coordinate plane with an x and a y, um, axes? So let's just take a look. So some things you're going to have to keep in mind when you're graphing an inequality on a coordinate plane. So we can't shade to the right or left unless it is a vertical line. So we're going to either be shading above or below the line. So let's just take some preliminary notes first. So here's a little key that you can use when you're graphing, and then you'll know which way to shade the line once you're done. So if it's greater or greater equal, you shade above the line. All right. If it's less or less equal, you shade below the line. All right. And then there's another thing you have to keep in mind too. If it's less equal or greater equal, okay, so the key word is going to be equal in this case, it's a solid line. So remember when we were dealing with the number line, we use an open or closed circle. So a solid line would be like for a closed circle. Okay. If it's just a greater than or less than symbol, then we're going to be using a dashed line. Okay, so that part you'll have to know, like how to shade the line, and then whether or not it is a dashed or solid line. Now there's one stipulation, and this stipulation will be for vertical lines. Now vertical lines look like this. They'll start off with X. They won't have a Y in it. So you might see X is greater than 2. So that would be like a graph of a vertical line on the x-axis. Okay, so here's your x-axis. Say this is 2. So that would be like what we call a vertical line. So there's no above or below a vertical line. It's either left or right. So if you were to shade this, greater or greater equal, you shade to the right. And if it's a less than or less equal, you shade to the left. So that's the only one that's different, because there's no above or below for a vertical line. It's either left or right. Okay. There is above and below for horizontal, but not for vertical. All right, so let's go back to page 10. And on page 10, you're going to graph it just like we graph in slope-intercept form. You start with your B first. So it says, what is the corresponding line? So that's just going to be y equals 2x minus 1. Because when we graph equations, guys, we're really graphing it in the equal form and not in the greater form right now. What is the y-intercept? -1. You can get that by looking at the problem. What is the slope? 2. Then you have to figure out if it's going to be a dashed or solid line, just like whether you have to figure out it's an open or closed circle. So since it's just greater than, it's going to be a dashed line because there's no equal sign under it. And since it's greater than, we shade above. Oh, sorry, a circle below instead above. All right, so we're going to be shading above the line. All right, so let's graph it. We'll start at -1. We'll go up 2 over 1, up 2 over 1. So let's get at least 3 to 4 points. Okay. And then after that, we're going to do a dashed line. It's not going to be a solid line, so when we're not going to actually connect them. Okay, dash means, you're not connecting. And simply, what that will simply mean is that those points along the dashed line would not be a solution to this inequality problem. Right? That's what it means by a dashed line. Same thing if you have an open circle on a number line, you're not including the number. So we're not including the points. So shading above means you just shade above and just draw lines. You don't actually need to shade. Okay, just draw lines to show that those would be the points that would be solutions. Now, a lot of times on your on a standardized test, you might see something like they ask you to test a point. So they might say, is 0, 0 a solution to this particular graph? And even though I made the dot a little bit bigger than I should have, 0, 0 would fall into the shaded region. Or if I say, would this point out here be a solution? What would you say? No, because it's not in the shaded part. Trash. Okay. If I ask you for a point that's up here, would that point, any point in here, be a solution? Yes. So anything along the dashed line, okay, or the shaded region would be a solution to the inequality. All right, give me a second. All right. All right, so let's move on down to the next example. And we don't need to fill in those little steps in the middle. We're just going to go ahead to example 2. So in example 2, the corresponding line would just be y equals negative 3/4 x plus 3. The y-intercept is 3. The slope is negative 3/4. So we're going to start off now by looking at the inequality symbol. Since there is a solid line equal sign under it, it will be a solid line. But it is less than, so we're going to be shading below. So, and it makes sense. Less means under or below. Greater is above, okay, higher. So let's start at positive 3. And then since the slope is negative 3/4, I'm going to go down 3 and then over to the right 4. I can also go up 3 and over to the left 4. Okay. And then this is a solid line, so I'll connect using a solid line. And then I shade below since it's less equal. So if I asked you, is 0, 0 a solution, what would you say? Yes, it is. Okay. And that's all it is. I mean, you guys know already how to graph and slope-intercept form, so you just got to make sure you don't, where there's a dash or solid, and make sure you're shading the line correctly. All right, let's move to the next page. Okay, so that will be page 14. So here we have to actually solve for y first. So we need to solve it for y. So I'm going to subtract 3x. So that'll give me 6y is greater than negative 3x plus 12. And then divide by 6. So that will give me y is greater than negative 1/2 x, because 3 over 6 reduces to negative 1/2, plus 2. So that becomes my problem in slope-intercept form. So my corresponding line is just y equals negative 1/2 x plus 2. The y-intercept is 2. The slope is negative 1/2. And since this is greater than, well, first let's do the dash or solid. This will be a dashed line since there's no equal sign under it. And it's greater than, so we're going to be shading above. Okay, so we'll start at the y-intercept at 2. And then our slope is negative 1/2, so I'm going to go down 1 over 2. Down 1 over 2. Okay, and then we'll do, like I said, a dashed line. And this is shaded above. Is 0, 0 a solution here? No, it's not. It's not in the shaded region. And any points along the dashed line would also not be a solution. So I'm going to do one more. So we need to solve this one for y. So when I move the 4x to the other side, I'm going to have 2y equals, and I should not say equal, 2y is less than or equal to negative 4x plus 8. Divide by 2. So y is less than or equal to negative 2x plus 4. My corresponding line is just y equals negative 2x plus 4. The y-intercept is 4. The slope is negative 2. And here we will have a solid line because of the equal sign. And since it's less than, we will be shading below. So we will start at the y-intercept at 4. Okay, our slope is negative 2, so I'm going to go down 2 over 1, down 2 over 1. I'll make a solid line. And then shade below, since it's less than. Okay. Are we okay with that? All right. Now, the last one is what type of line? What type of line starts off with X? Vertical. Okay, so what we're graphing is a vertical line at 4. So I'm just going to go ahead and make a vertical line. It will be a dashed line. And since it's less than, we're not shading above or below. We're going to actually be shading to the left. All right, so make a dashed line. And then just shade to the left. That's it. The slope for vertical lines is undefined, so you don't need to write anything for that. Any questions?